Thank you. Welcome to the LinkML community meeting for May 21st, 2026. Yeah. Updates in the last month that we've had is that 1.11 is released, and more importantly, 1.11.1 is released. I had a little bit of a mistake using the GitHub Great Release, and the added one got an extra pull request into the from 11 RC3 into the release. So that one is what 11.0 should have been. As always, that's what that one means, I guess. Our activity last month has been awesome. 69 PRs created, 63 merged, 82 issues created, and 65 closed. And I think that was a big jump in the number of closed, and most importantly, the 39 unique contributors, which was amazing. And we're thinking about a LinkML workshop where we can get like-minded people together for show and tells over a bigger span, to take more time than just an hour in this community meeting. And so head to that link to get into the chat. No. Okay, I'm not going to get into the chat. Head to that link, discussions 34 to register your interests. Our recently closed PRs, I'm not going to read all of this, but as you can see in the generator side, Shackle, OpenAI, the deterministic RDF fix, lots of changes there, lots of work in LinkML map, and then Noel's been doing some amazing contributions of infrastructure work along with lots of folks. One more for me. Contact us to talk at this community meeting, or just to get help or ideas at the channels that are listed there. We'll get started for real with help me with let me know if I mispronounce, but Inge Vejsbjerb, research engineer at IBM in Dublin, talking about managing AI risk. Stop sharing.
Hi, thanks. You did a great job of pronouncing there. So yeah, my name is Inge Vejsbjerb, and I'm a research engineer. I'm a software research engineer in the Interactive AI lab in IBM Research in Dublin. And we have an office there that's based in Trinity College. I will just try and attempt to share my slides. 1 second. Okay. Okay. Can you see my screen?
Yep.
We see the Zoom screen.
Great. And bear with me for technical things because I can't see you guys anymore now. So yeah, so I just want to introduce the AI Atlas Nexus project to you. Noel suggested that you would be interested in maybe learning a little bit about how we're using LinkML for this project. So just to kind of summarize what it is, we're doing some work in the area of AI governance because organizations have significant risks of legal, financial, and reputational damage when AI systems are inadequately governed. This is kind of becoming increasingly important. And so we're hoping to provide some open source tooling to help developers identify and prioritize risks, recommend benchmarks, and propose mitigation strategies and actions for AI systems. And so our team, we would like to foreground kind of responsible AI, not saying don't use LLMs, but just to understand the risks and also the opportunities that are involved in using those in your projects. And so just kind of promote transparency and accountability, bridge gaps in governance infrastructure, and lower barrier of entry to developers who want to implement responsible design when they're making their Python code. And so we're hoping to enable collaboration from the community for governance, tooling, and content. So just as a kind of a scenario, we might have a developer who has a great idea for an application, and they're going to make a portfolio advisor financial planning tool. And they suggest that with an LLM, they can have something up and running in a few days. What if it leaks private data? What if it ends up being biased? What if it gets me in trouble with my company? And which risks are the ones that I should care about? So motivating this, then we have IBM has previous work with the IBM AI Risk Atlas. This is a catalog of risks in generative AI, foundation models, and machine learning systems. And so this work was done basically mainly out of our Yorktown group in the US, and this is all published on the IBM doc site. However, it was kind of in a documentation form as opposed to something which is available to make use of in software applications. So we wanted to store it in a more structured form and enhance accessibility to this risk information by software and allow it to be operationalized as part of governance processes. One thing also that was missing as well was that we wanted to understand how the risks would relate to other taxonomies, benchmarks, and actions. So our initial vision, which was a usage governance advisor, which we did in conjunction with our teams in Yorktown and Zurich, which took a user intent. Say, for example, somebody wanted to make a medical chatbot, and kind of identified the risks involved in that use case through a series of kind of questionnaires and auto-assisted questionnaires, kind of recommended models that would be used, risks of using it, and provided kind of evaluation of mitigating actions and risk evaluations. And so this was work we did with that larger team, but really the main piece that we felt was kind of useful was this metadata store and knowledge graph. And so that is where the kind of LinkML piece came in, particularly by our team in Zurich. Chris Giblin suggested the use of LinkML for this kind of piece. So I can't actually see if there's any questions or anything like that. I can't. Please feel free to interrupt if that's all right, okay? Because I can't see the screen for hands up or anything like that when I'm sharing. So. But basically, we wanted to use this to kind of empower developers to build and integrate governance capabilities. So we kind of wanted to take that model of an AI system and model of AI risks and all that, and allow developers to be able to use that in their own kind of toolkits and things. So what is actually in the project at the moment? We have a resource repository with a catalog of governance assets like datasets, benchmarks, risk taxonomies, and controls with data from different sources. The IBM Risk Atlas, NIST, MIT AI Risk Repository, and a few more as well. We have customizable policies, which are kind of structures for describing the AI systems and kind of rules about them in one coherent schema. We use these to produce an AI systems knowledge graph with structured mappings linking between the different items. And then we have the toolkit, which is like a small Python library, which allows you to kind of query and do different little risk management tasks. And it is ideally customizable so that you can bring your own risks or your own templates or things depending on your organization's needs. We also have some kind of work where this is feeding into agentic governance pipelines. So we have this intent to governance workflow, customizable risk assessment, where we do policy distillation with an LLM as a judge solution. There's different mitigations and controls, which are brought in from sources such as the MIT draft mitigation taxonomy and Credo as well. And we have various external collaborations. So, for example, the MIT AI Risk Repository, we're coordinating on integrating the content from those kind of domain experts. We have some coordination with Red Hat, also with Nokia Bell Labs. We did some kind of EU AI Act risk classification for use cases. Trinity College, University of Notre Dame, Elias, and the every eval ever effort, which is a metadata effort for AI benchmarking. Oh, yeah. So we have provided a kind of ontology or schema that's kind of combining an AI risk view, which is all the things like the taxonomies and actions and risks, with the model view, which includes the models and model evaluations. This has been modeled using LinkML. LinkML is appealed because of the flexibility of the YAML authoring, also that you can output the data into different formats depending on your kind of case that you need, especially because we're kind of making this as a prototype. So that has actually been very useful. And then also the fact that you can output it into the pedantic classes was super useful for us as well. Yeah, so we are basing our kind of modeling largely on the existing standards, the AI risk ontology and the DPV, both of which are the Adapt Center and Trinity are involved in producing those, and we have tried to, they model systems from a risk point of view. We have lean heavily on this, but we modify it to extend the risk concept to include like our existing risk taxonomies, capability taxonomies, and other artifacts. And then we produce a knowledge graph, which contains the risks and other data. We have different things like documentation. We've tried to ground everything back to link to technical documentation or publications. AI tasks, actions, capabilities, stakeholders, different kind of taxonomies, and so on and so forth. We are using the simple standard for shared ontological mappings for the to hold the mappings between the different risks in the different taxonomies. I think this is quite important for us as well, because we then have a record of where the mapping came from, because, like saying that one risk is related to another risk or closely matched kind of does have, it's a point of view, that way. So organizations can then bring their own mappings to bear as well, either on their own risks or on the risks that are in there as well. And then they use some Python scripts to help bring that back into the graph. And so we have like 15 different taxonomies. 9 of them are risk taxonomies, different documentations. So just to give you an idea, I don't know if you can see this on the screen, but just the kind of things. So this would be a description of a document, in this case, foundation models, opportunities, risks, and mitigations. Here we have kind of what is like a risk or an action. This is an action here, which is like a control for a particular risk. And who's going to do it and all of that. And then we have over 500 risks at the moment that can be used. The Python library allows then access to convenience methods for accessing content, exploring the risks. We have a set of notebooks and all that show you how you can bring your own content, how you can classify risks, how you can uncover the domain from your use case, auto assisting using questionnaires, using chain of thought, stuff like that. And I can show you any questions so far, or will I kind of give you a little demo?
Go ahead with the demo. We're just sharing the links and are excited.
Okay, thanks. Yeah, so let's see. Okay, so I'll just do it on the slides, because just for demo quickness or whatever. So this is like a little Hugging Face, sort of a toy example of what you could do with the. I don't know why it wants to play. Let's go back 1 second. Now, so in this case, this is a Hugging Face space, which has like an implementation of the Risk Atlas Nexus toolkit, the Grad.io app, right? So it just takes as input a simple description of an AI use case We've chosen a risk taxonomy. In this case, we are interested in risks which come from the IBM AI Atlas, AI Risk Atlas, and a particular language model to use. We then have we can see here that we have, this is our example use case. When we go to the next one, we can then see that the potential risks are then displayed. So in this case, it's estimated that using an LLM prompt that, I don't know why it keeps going ahead, but anyway, here we go. So we can see that it's chosen harmful output, gives the description, and it surfaces the relationships, the related risks from other taxonomies. And also we can see then that it is, for the harmful output, it's suggesting what actions you might take to mitigate this. Then you might have, you can also see the different AI benchmarks that might be relevant to you for your use case. And then we also just have a kind of a small diagram that situates this risk in its landscape. I don't know why it wants to keep going ahead, but anyway, so I go back here. Yeah, so then we have, this is another one, say for example, you can see that also it's, if we choose the risk lack of model transparency, you'll see the different risks from the other taxonomies related to this, and the different kind of mitigations that it found. And you can also just download this into to JSON as well if you want. This is kind of a brief overview of the system. What all is in it, the different resources we have, components, like tend to risk identification, tend to AI tasks, stuff like that. And so what we're looking at the moment is some related projects to show you kind of what you could use this library for. In this case, one of my colleagues has made a piece called GathGuard, which I don't know what my PowerPoint is up to, but it uses the AI Atlas Nexus to instantiate a governance layer around an LLM. So, it's basically looking at inputs from kind of different things and doing drift monitoring and policy evaluation. And you can see it uses the Risk Atlas Nexus as a dependency to do kind of risk identification on that. And some links about that if you're kind of interested in that. Or another one we have is Media Skills Compiler, which is if you're familiar with skills, say, for example, using the kind of Claude Code or any of those, you might have a skill which helps you do a particular AI task, and it takes the natural language AI skill and it produces an instrumented Python program using the Melia library. But we use Risk Atlas Nexus to kind of identify risks, and then with hooks, it runs different other kind of guardrails on it to produce a certifiable kind of auditable Python program. I have an intern as well who is working on, he's interested in the area of AI benchmarks, and he is working on a workflow which generates descriptions of the AI benchmarks automatically. So he takes in loads of documentation and metadata, composes it into a benchmark, using a particular schema, which is then defined as an object in LinkML. He has a validation phase where he does fact checking and stuff like that, and comes out with the final benchmark part. We also have Noel, who was encouraging me to show you kind of what we're up to with this today as well. It has a project which is a reference implementation of operational AI governance built on open data. So this is a LinkML project, and it has he's leaning on the AI Atlas Nexus as well to show this data. He has a CLI, fast API backend, and a web UI to explore the risks and different things that are in there, and a graph database. And he hopes to present this to you guys as part of the community projects piece, I think. Essentially, we're trying to build collaborations both from developers and also kind of academic collaborations in Ireland and around the world. As I was saying to you, we have some collaborations with the Adapt Centre in Trinity, with the Notre Dame. We're working on this benchmark cards piece, Nokia Bell Labs, MIT AI Risk Repository, Elias and Cicero. yeah, I mean, so overall, there has been interest in the project, but largely it is still kind of in prototype phase. So at the moment, problems that I'm looking at the moment are kind of being able to run more kind of complex SparkQuill queries on the underlying graph. So I'm adding a Pyoxygraph based explorer. I'm also working on comparison equivalence to be able to compare one AI system to another. And I have a kind of a small implementation of a natural language query translation to SparkQuill. So say, for example, here you can see which actions address which risks. Show me the action risk pairs defined by the NIST AI ORMF taxonomy. And it is querying the underlying graph. It like creates a SparkQuill statement based on chain of thought stuff and then comes back with an answer. So that needs kind of more work at the moment before I can kind of put that in. So that's one piece that I'm interested in. And then also rules, like rules and policies. So I'm interested in hearing any thoughts that anyone might have as well about kind of these derived subgraphs, because we can validate against a LinkML schema, but we can store the rules there. But then at runtime, when we actually want to apply the rules, just different ways of doing that. So I have like something which is applying rules in preconditions and post conditions and things like that. So I'm definitely interested in getting feedback on any of these things from the LinkML community, So okay. Thanks. Have you any questions? Or
This is great. Thank you very much, Inge. It's just to understand, because you just asked it in the very end. When you say you apply the rules, do you mean for validating instances or validation, or and is this something that's
no,
not
kind of at runtime more so, like so say I store, so an example would be, should I have that example in my slide? Let's say no, I don't think, let's say this algorithmic hiring. Let's say I have a case in I have an AI system that does some candidate screening, let's say, and I've made the AI system and I apply it, I deploy it, and I put it in New York. And there are various regulatory obligations that will go for that system because it is deployed in New York. However, if I move that exact same system to somewhere within the EU, instead of having New York, whatever it is, employment thing 144, I have some obligations under GDPR or different other obligations about auditability and transparency. So nothing about the actual data has changed or the system, just like is located in, that way. And so if I have a set of rules and then at runtime I want to kind of trigger them, or I'm just kind of wondering what approaches do you guys take to things at runtime rather than validating that it's valid.
So I will let other more experienced modelers answer this question if they can. I don't think it's very easy and it's always like the same in every instance, but my initial sense would be that you would probably model the rules as a primary part of your model rather than using the kind of precondition and post-condition features of the LinkML meta model, let's say. But maybe I'm wrong, and someone with more experience would say, "Ah, yeah, you can actually do that." But yeah. Anyways, it's a super interesting case. So I'll let someone else speak. I think Anne, yeah, you were first. So if you want to go first.
Yeah, so if you have the data converted to already a graph form, something that we were looking at is using Shackle. So it's outside of LinkML really, but there's a paper I posted in the chat that we're sort of using, and I think it's pretty relevant because you're asking for modeling, different regulatory requirements in kind of different environments, right? So yeah.
That'll be super useful. I'll have a look. I'll have a look at that. Yeah, I was just like, because I know that we're all often doing the same things again. So if there's any pointers for stuff to read, that would be really great. So And I see Harry, do you have a question as well?
Yes. So yeah, this is fantastic work. Thanks for presenting on it today. Um, One thing that we've long been trying to accomplish in the Bridge to AI projects, where I am particularly focused on standards and especially tracking data standards that are out there in the biomedical data ecosystem, is having a consistent way to index all the standards that are out there, but then try to figure out how many of them actually have formal definitions that we can then reapply to data. Because I guess the major challenge there is, well, many of these standards are kind of loosely defined. It's not so much like a W3C standard as much as it is, a paper that somebody released once where they said, hey, here are the rules that you really ought to follow. Um, but it sounds like much of what you've been talking about would be able to take these standards closer in that direction. Even things like the agent skills work that you're talking about, where
Yeah.
it's kind of taking things farther in or closer to a programmatic direction. So
Yeah.
just mostly to say that, yeah, I may want to follow up offline and ask a few more questions about this work, but this is definitely an area where we are also interested in not only taking advantage of the LinkML ecosystem, but
Yeah.
also, yeah, keeping track of what groups like yours have been doing in terms of, kind of pushing standards towards more of an interoperable and implementable direction.
I suppose, yeah, that the kind of interoperability part was quite important for us because there are lots of there's all different kind of research groups doing different things, even within IBM or other people that are picking up the project. For example, there's like a NASA IBM um, joint project as well, which is using some of the outputs of this. It's kind of like we want to keep them. This is one of the really good appealing things about LinkML is that we can really very easily redefine these things and reload, and that it can be that you can kind of modify it as you need. However, then when it comes to actually publishing it as a standard, I don't know whether there would be pros and cons about that in that way because um, but yeah, I think Noel has been urging us as well to have better like IRIs and better like register our schemas and stuff better. So I really do think that is a key next step for us to take, So yeah. But definitely, if you would like to learn more about, say, for example, the Media Skills compiler, I can share some links and please drop me a message or something. Yeah, be happy to
Yeah,
talk about
fantastic.
it. Yeah, thanks.
There was one more question from Corey in the chat. I don't know, Corey, if you want to say it out loud or maybe.
Yeah, hey, just curious as you were speaking about some of the benchmarking work, if you were looking at the Croissant AI metadata standards at all, if that had come into your view. I've spent some time looking at those. It seems like they're not all benchmarks are using them, but some of them are. And yeah, just curious if that had come up for y'all, and it would be cool to see some of that work getting into the LinkML ecosystem too.
Okay, yeah, I will mention it to Aris, who's kind of leading that work for us. So we work together with some researchers at University of Notre Dame to come up with this like benchmark card schema, which describes different attributes that you might want to know about an AI evaluation benchmark. And so then Aris is going through this, trying to automate the process of producing these with LLMs and then like fact checking it and stuff like that. So I'm sure I will ask him to look into that and see how the two things can be related, croissant.
Yeah, I just posted a link to it as well. It's a funny world that we're in. I feel like we're seeing this for benchmarks, but also in broader places. It's like, are these standards for the dataset producers to be adhering to and producing metadata artifacts alongside their assets, or is it downstream consumers who are then running these extraction pipelines to do it in a more bespoke way? It's really interesting to see the ways this is happening for you, and I think there's a lot of parallels across other domains as well.
Yeah, specifically in the benchmark space, I suppose as well, it's like people are just kind of randomly running benchmarks, but they may not be suitable or they may not be measuring what people think they're measuring.
Hmm.
So kind of just trying to reduce the burden of producing both human and machine readable metadata about these evaluations. So yeah. Okay, thanks so much for giving me the chance to talk about the project, and please do reach out if there's anything that you're interested in. I can share some links or with other members of my team. So thanks. Okay,
Thank you.
thanks.
Our next speaker is Joshua Send, CTO of TypeDB, talking about why TypeDB is the natural backend for LinkML. And I'm actually kind of curious. LinkML support is new, so the full rule support and all of that aren't there. But maybe it's actually a pretty natural segue to like a way to um, uh, uh, control your data at rest or validate your data at rest. Able to stop sharing.
Hi, everyone. Let me just pull this up. Allow. Let me just share the whole screen. All right. Can you guys see my presentation?
Yep.
Yeah. All right. Hi, everyone. I'm Josh. It's so nice to be in the community and meet everyone and present. This kind of came from a general enthusiasm I encountered while I was discovering LinkML, and I'll kind of talk about it a bit more. But really, I want to talk about the philosophical and kind of practical alignments between our two projects and what could or could not come from that. And yeah, I just kind of, this whole thing was kind of birthed from me discovering and being really excited by LinkML. So if I get a little overexcited, which is totally not my personality either, just be aware that might happen. Um, so yeah, TypeDB, just to start from what we are and then dive into how we kind of have some synergies, is TypeDB is a new kind of graph-like database. We're not that new at this point, but we're kind of had a couple of R&D phases and development phases where we were productionizing the system, and we're in the process of expanding the usage and going to market and stuff like that. So we're now looking outward a bit more than looking inward at the technology. But at this point, we have a stack of things that interoperate with TypeDB. We're a production level database. There's 3 or 4 different ways of running TypeDB. That's the first 3 things on the list, including a fully managed cloud distribution. And then we have all the ways you can interact with TypeDB. And one of them is the web-based studio on the right, which I can, if we have time, I'll just show you quickly at the end. But besides that, we have integrations for drivers and CLI and integrations with MCP and NetworkX and some AI skills and stuff. But the phase we're in right now is the core product is quite stable and very usable. And we're now looking into the wider ecosystem and communities that we can integrate with. And that's kind of where this talk is really being placed in my mind. So yeah, thinking about integrations and how we can interact and collaborate. So, all right. So how did I discover you guys? We have someone in our community because we're open source and we live on our Discord server quite a lot. There's a guy called Gully who approached me saying, you should check out this project. And then he'd already written a schema generator which mapped LinkML schemas to TypeQL schemas automatically. And then if you check out the PR thread where he was linking me, I just have this long comment how I was like, holy crap, we should be working together because this is a crazy alignment and philosophical similarity. And then I was digging through the web a little bit, and I found out that way back in 2023, our teams had actually already interacted. And I think basically what happened was our wider team didn't recognize how similar and the alignment between our projects. And so, yeah, it's kind of cool to see that there has been already a touch point, and I'm just sorry it's taken so long to pick up that communication. So, right, so let's start from the top philosophically. LinkML as far, and feel free to correct me on everything. I've done some research and reading on LinkML, and I kind of did some research for the presentation and stuff, but just let me know if I have any errors. As far as I can tell, LinkML's core philosophy is to bring structure to data. That's the front page of the website. That's kind of the through line. And you're trying to make it easy, good modeling, accessible, and you want to be able to continuously validate your data against schemas in kind of an open science, open core, open source kind of ethos, right? And so if we look at what we do is we have tried to build a database that's as close to as how you would think about your data as possible. And to do that, we give you a type system, which is your schema, and then your data is always validated against your schema, and your data can never go out of sync with that. And we too have an open source philosophy where most of our code and almost everything that is not enterprisey is open source, either Apache or MPL, Mozilla licensed. And the goal of both projects is to really give users and developers the right tools for your data. And it's really interesting to me that there's probably hundreds of ways to build abstractions. If we look at the variety of programming language that exist in the world, there's many different ways to build systems that make life easy. And our two projects have ended up with really similar abstractions, which is super interesting to me and very validating for me as well, because we've been doing this for a while. And there's not that many ethoses that I've encountered that really share some of these core features. And just going then one step down from there, from the philosophy to what that looks like, is we've both fully bought into schema first, right? You define your model. You use types to define that. You have a meta model. Your vocabulary is a little different. You have classes, slots, types, and enums in your kind of higher levels meta model. And we have entity, relation, and attribute role type and role types as our meta model. And there is a mapping here that I'll show you. And you support things like polymorphism with reusable slots, mix-ins, and subtype polymorphism with inheritance. And we too have single inheritance and composability with polymorphic operations. And then from where you go from those operations is a little different, right? Which makes a lot of sense. You're a standard supporting vendor agnostic outputs, validation of text data, making it easy to be transportable. And we've gone to, now let's take this and make it executable, and build a production level database with ACID transactions and all the tooling around it. So the divergence is really down there at the bottom. And TypeQL is the name of our query language in which you define schemas and do data and operations with it. Right, so going from here to just a very brief look at mapping how our kind of meta models convert, and we'll do this more by example a little bit later. But you have classes for us, those are entities and relations, depending on what your slots are. You have subtyping, you have slots, either scalar slots or primitive slots, which become attributes for us. And you have object value slots where you range over classes, which become simple binary relations for us. This took me all of about 10 minutes of reading your docs to figure out. So I'm like, I can't imagine that there's many other systems where it's so easy. At least the intuition of it should be so easy. Maybe I'm a little bit off on the details. And again, I apologize if it's not, you don't use the terms of scalar or primitive slots. That's just kind of how I interpret it, or object valued slots. So when you assign a class range. But that felt natural to me and like a nice middle ground. And all of your stuff around identifiers, required, abstract, those are all annotations over our schema, which we'll see in a second. I don't want to spend too much time here, but just show some examples, right? So on the left, you have a LinkML schema. You have your name things and your gene and your disease, which are classes. And for us, those become entities. Your slots here are all primitives, essentially, right? Strings or strings essentially in all of these. And then you can see on the right, we have also an entity type called nameThing, which we can mark as abstract. And then they have two attributes that they can own, ID, which is a unique key or name. And then you can have gene, which is a subtype of nameThing. And a bunch of the stuff that you have encoded in text, we can turn into this executable format in our schema language. And this is a defined query that you send to your database. And if you execute it, your database will have this populated as its schema. So our type system and the schema are one and the same. And then you can use that as an executable queryable format and validation for your data and to execute instance operations against it. So like, let's find me all the named things in the database is a question you can ask on the data level rather than the schema level based on what you have in the schema. So that's classes and inheritance. Relations, so you have first class relations when you have this marker, right? And for us, we have first class relations as a type in our meta model. And I said in the beginning, we're a graph-E database. We're kind of more like a hypergraph database. We have first-class relations with any number of connections in them. And this is how we do it on the right. So you have a relation class that has multiple slots that are, I would call like class valued or object ranging. And on the right, we say, let's define a relation which has different roles, subject, object, and evidence. And then we wire them up with a plays. So you can say an entity gene plays this particular role in the relation, which will now allow the data to express that you can have these relations connected to these entities via this role. And that's basically exactly what we've done on the left by saying that the subject range is genes. For us, you can actually reuse them. So you would like being able to say on the left that you have your gene disease association can have a range of genes or proteins or something else. And for us on the right, you could extend this saying a gene plays this role in the relation and another statement which says some other type plays this role in the relation. It's just ours is decomposed and yours is more coupled in this place, and it's decoupled in slots, which we'll look at next. Any questions here? I'm just whizzing through a little bit because I feel like a lot of this will probably be pretty intuitive to you. It's just a vocabulary and like unit of abstraction difference, essentially. All right, so slots also maps very cleanly to me. Primitive slots become attributes. So we actually encapsulate value types like a string inside an attribute type, and then you can actually build type hierarchies over your attributes as well. I don't know if your slots can be subtyped. I believe they can, but we can do that on the right-hand side as well. And then if you have a slot that is a class ranged item, then on the right, we can just pick a convention and say these are binary relations which have an owner and an owned, and then we populate the range with a plays again, which is a very direct mapping. Something that I find is cool that maybe isn't so easy to do in other databases that you serialize to is multi-valued properties, right? So for us, we have the idea of hyper edges. So if you want your range to be multi-valued, for us, you just relax the cardinality restriction on the like relates owned over here, right? So this is just saying we don't just want 0 or 1 owned employment event, but you can have an infinite number in the same relation, right? And you can restrict that to any range. You can say, I want 0 to 1, I want exactly 1, I want 0 to 20. You can 10 to 20, like any range is possible. And you can do that on anything. You can do it for us on this one or on this one, but I think when we're mapping what you have, this multi-valued true becomes exactly this multi-valued one. Our ranges could also be relationships. So I believe I haven't checked in your docs or read up too much on it, but I don't know if your ranges could be classes that are relations, which will allow you to basically nest relations into relations. And you can do that in TypeDB as well. So you could assign that this, rather than being an entity that plays this role, you can have a relation playing the role, and you can put a relation in a relation in a relation. I did see some question pop up. Sorry, I'll have to check in on the end, or if someone wants to read it out, then feel free.
Question yet, just comments so far.
All right, cool. All right, we'll continue. Right, so one thing that isn't that well mapped right now is mixins. And really for us, we have to decompose it. So you have single inheritance and composition. We also prefer composition. It's a way of doing polymorphism without having to assert something is something else. It's funny that this is coming up now. As I discovered on LinkML, we too want to implement something like a trait or interface where you can bundle a set of these kind of like traits, like mini traits. We call them capabilities or traits in our internal systems. Each particular thing you can play or own is a mini, like a trait or capability, and you can bundle them together into a trait or interface in the future, and then say that a person implements this trait. The same way you could have a mixin applied to one of your classes. And I believe you have both mixins and interfaces, and I apologize, I'm not well versed enough to really have dug into the difference between them. But essentially, this is something we will also cover the gap on and become even closer on. Okay, so let's just look at one thing that I think that TypeDB does really well compared to some of the other databases that are more graphy. In LPG and RDF, you have to do reification if you want n-ary relationships. I believe RDF 1.2 makes this a bit better, but I still think it's really ugly. So in TypeDB, you can have relations of any number of connections, of any number of roles, multi-valued, any of that stuff, just as a natural extension of the same syntax. And one of the things that I always break my head over in RDF and both RDF and LPG models of hyperedges with reification, where you turn essentially an edge into a node, is now if I want to query something polymorphically, some of the things I want to return might be actual edges because they're binary, and some of them might be nodes because they've been reified. And now I'm trying to return a set of edges and nodes together for the same item. If I'm looking for all connections as a type, some of them might be reified and some of them might not be reified. And in TypeDB, that will always just come back as a relation, either a binary relation or a ternary relation or some n-ary relation. And so that feels very natural to me. And I still can't quite wrap my head around the RDF version of that, but I know Neo4j is particularly limited on this front. All right, so that I think is an interesting thing. And just to be a little bit clear on what isn't immediately obvious to me after 10 minutes of reading the docs, but so we've covered mixins, default values, TypeDB doesn't have yet. We want to do it at some point. Boolean slot expressions, haven't quite read too much on that. Some of the constraints we have with like required or uniqueness and stuff like that map, but some of them don't. So it may not actually work there yet. Arrays we don't have yet, so everything is a unordered set. On the medium-term roadmap, we have the idea of lists and ordered sets being added as well. Both for primitives, we'll have vectors and lists, and we'll have a way to order the parts of your graph that you're building. So you can say it owns these 10 these 10 colors of these 3 colors of the traffic light are this order. So it owns RGB or whatever, something like that, red, yellow, green, in this order, not just as a set of colors. And subsets. So again, haven't read too much onto it yet. There is a bunch of stuff that I think maybe is more rooted in RDF world, particularly about like shareable ontologies, universal IDs, stuff like that, which may be emulatable or not. TypeDB is designed for more closed world systems rather than federated data systems and open world systems. So we find a lot of adoption in companies that are building knowledge graphs or their own internal representations and building sophisticated data models rather than people trying to do federated queries. And to be honest, from talking to RDF people, it's also the federated part of semantic web hasn't been as successful as some of the other parts of the RDF vision. Maybe that's changing again now with AI stuff, but shareable schemas definitely is a thing. All right, so, and then here's kind of my ping back to the LinkML community a little bit is I think TypeDB is a very natural serial, like executable format of LinkML. And the vice versa is actually something we have completely got a gap in our ecosystem. We haven't got a good standardized serialized version of TypeDB databases that are not in a proprietary format. Like we can convert it into TypeQL queries, we can convert it into a protobuf format of binary essentially, but we haven't got this intermediate exchange format that would then let us interoperate with other ecosystems. And I think like your project is the closest thing I've seen that would let us capture the semantics of TypeDB in a really efficient way. And so I think while there is a lot of space to implement LinkML for type to export to TypeDB as a backend, I think it'd be really cool to do the other direction as well, where LinkML becomes almost like maybe if it works out really well, almost the default export version of like if you want an exchange format for your data that is vendor agnostic, we now have an escape hatch because we're still a young project. People are potentially a bit worried about adopting a new technology, and you give them this way out, being like, look, if you're worried at any point, export it to LinkML, and you have this entire ecosystem you can plug into. And all the validators and generators you have, all the ecosystem you develop become accessible for our community. And if you go from LinkML to TypeDB, you get access to our community. I just feel like there's a lot of interplay there that could be super interesting. One thing I haven't touched on, which I'm going to have like 2 minutes for this, but in a demo, I will show you how to query the schema as well. So our schema is executable as well as the data. So that's kind of a cool thing we can do. Let me just actually skip to that. So let me see, where's my, here. All right, so this is just our studio. You can spin it up if you have a running, I have a local TypeDB instance running. You can load a sample data set. I've just got like a bookstore data set, which has some schema, right? So you can see the schemas on the side. We can look at the schema as a graph in this shape here, where the diamonds are relations, and these are the roles between things that are implemented by, say, an entity. So here's a user that is playing the recipient of a recommendation role in a recommendation relation, which is connected via a recommended to, I'm guessing this is a book, yeah, right? So this is a visual way to look at your schema, which is also maybe an interesting way to examine a LinkML schema if converted to TypeDB. And we can also do this stuff where if you say match dollar entity, find me all the entities, and it'll retrieve you all the entities. Or I want all the entities that own some attribute. Maybe not all entities own something. Okay, or if you want to just find the ones that own a name, right? So you can actually use this as a way to query the model of your data, not just the data itself. And then you could do very fun things like, okay, find me all the types that conform to this pattern, and then say all the instances that are mapping to that type that has been constrained. So you can query dynamically across the schema, the model, and the data that conforms to the model in an integrated system here. So that's why I think maybe in the explanation of like, this is an executable format of schema and data that is very close to LinkML is kind of an interesting angle. I'm going to stop there. So there's a couple time for questions because I'm seeing some stuff pop up here. But yeah, so just so everyone's aware, there's some stuff to do next. It's an early version that's been written, and I would love to keep the work going and go further. Thanks.
Thank you. I think Mark is the most excited to ask a question. So go.
All right.
Yeah, I am excited. Thank you very much. You did very good homework, and you're evangelizing for your company, but I feel like you really do have a good understanding of what we could accomplish together, and I really appreciate that. Um, I mainly use LinkML to support a project called NMDC. It's mostly an environmental microbiome system. And we have data in both MongoDB, which goes through uh, uh, validation layer. It has a it has a process that validates the data against a LinkML. And then we also have some Postgres. And we have some database fatigue, but if this really were the right tool for the job, I would want to advocate for it. But the the real 500-ton elephant in the room right now is that we have to work within a mostly relational data lakehouse environment that the Department of Energy is advocating for. So to cut that all short, I am not only interested in the round trip between LinkML compliant YAML or JSON objects in a file system and TypeDB in memory contents. I think that having that as a round trip would be a huge win, but I am also interested in round tripping from TypeDB to a relational database. Is there any potential there? Do you have any sense of what is lost?
Mhm. I think the most easy and obvious way to do for me to do it in this case would be probably go back to LinkML and then out to relational. It depends on what exactly you need. Some emulating relational in TypeDB is very easy. Emulating TypeDB in relational may not be that easy.
Yeah.
So same with property graph, especially we have a feature called structs coming up, which let you emulate an arbitrary untyped property. And then basically emulating label LPG is trivial for us, but the other way around is not so trivial. So it kind of depends on how complex your schema is. If it fits in a relational model now, then doing it in TypeDB and mapping it to relational won't be that hard, I think, is my instinct.
Yeah.
But it really depends on like what do you need? Are you reading? Are you writing? Are you using it for validation? I'd love to talk to you if you shoot me an email or you can chat anytime, honestly. I'm very open to seeing how that would look and we can sketch something out.
Okay. Thank you, Joshua.
Thank you. Yeah, great question. I feel like there were more comments in the chat which I haven't looked at yet.
We love this tool that you just showed. We
All
really
right.
like the idea of querying the schema and the data together like this. And schema view might be something that did you run across it already as well in LinkML?
Sorry, was there a question there?
Yeah, no. Did you run
Sorry.
across schema view already when you were looking at LinkML?
Yeah, no, there's this thing keeps getting better, and we have an agent mode, so you can chat in natural language
Excellent. Okay.
and queries and stuff. And then there's a data explorer, which is tabular, so you can like look at and traverse your data, see who owns this address, and then click through your data like that, which is an interesting way to explore a hypergraph, essentially.
You've got one hand up.
Yes, whoever has a hand
Yeah,
up. Sorry, I
sorry.
can't really see.
Simon Kemper, working at the National Archives of the Netherlands. We've actually been using this combination for a long time already, TypeDB and LinkML, just like Mark Miller has. With a lakehouse at the beginning for converting eventually to TypeDB, because that's just the easiest way to use the data for context engineering or queries or whatever. So we're really happy with your product, actually. But yeah, I mean, the question just came up, right, with the relational, the transitions you would want to do. I just wanted to share that for our experience. Yeah, it's indeed really like you receive it in your lakehouse. LinkML works perfect for the kind of mapping you want to do together with SSOM. And then, sending it to TypeDB, that has been something that's actually been working for us quite well during the last year. The question I wanted to ask is basically just to both presenters, because if you combine this with governance as code, TypeDB would also be great for the kind of governance explorations of AI that we saw in the first presentation. Is this something that you both would be interested in exploring, or has it come up in discussions in the past? It's the first time I joined this LinkML community meeting, so yeah. I mean, it seems like it worked well with, for instance, what you see with Agoda, right? The governance of code infrastructure they're using there, where they're not really paying attention to AI yet, and the complex systems you need for evaluating AI, which we just saw, and then using TypeDB on top of that. That seems like a very good solution. Yeah,
I'm very open to working on that kind of space of collaboration. TypeDB really is good at layering lineage and meta models and annotations of data over other data, because you can nest those relations arbitrarily and basically compose schemas as well on the fly. So if IBM wants to check it out and come reach out, I would be very open.
Yeah, I mean, definitely if it's something you would like to follow up on, please do get in touch, because I do think there's a lot of kind of overlaps and the kind of things that we could do together. So
I will reach out. Yeah, thank you.
It would also be great, I think, for the European governments or just governance in general. It is exactly the kind of question they're struggling with, especially the Dutch. I mean, I know for the Dutch government, they definitely are. how to bring more transparency to, and how to really apply the governance in the strict way that we want to do in the EU. So that would be very exciting if you guys work together on that.
Yeah.
Thanks so much. It's a great suggestion. Thank you.
Thank you. Sorry, I didn't catch your name. Who just responded? Are you working with you're working in the archiving space?
Yeah, National Archives of the Netherlands. Yeah.
Oh, no way. I have another archivist in the US who's just published some papers about using TypeDB as an archiving.
Oh, great.
I
Wasn't
can
aware. Yeah, if you could send it, it would be great.
I'll do that.
Thank you, Joshua.
Any other questions? Very happy to take them, or shoot me an email. Over to Kevin.
You probably should jump off. People probably have, I think I have another meeting to go to. I just want to hang out. But thank you both for the presentations, and everyone. Keep connecting. The Slack is there. The OBO Slack of the Canal community to keep conversations going. Thank you so much.
Thank you all. Thanks. Okay.